Hello boys and girls, this is Mr. Kizik, and in this video we're going to be talking about basically the conclusions that you came up with in the activity last class. We will talk about the proofs later on here, but we want to just keep going and talk about these actual angle pairs and their relationships. So the things that you should have came up with for the different angle relationships are in this box here. If the two lines are parallel and then cut by a transversal, then corresponding angles are congruent, alternate interior angles are congruent, alternate exterior angles are congruent, and then the consecutive interior or the same side interior angles, a lot of you were saying yes, they are different, but what more specifically? Well, they were actually supplementary. And then also recall too, from the last chapter, we do have vertical angles that are also congruent, and then we also have linear pairs, which are supplementary. So in the various examples here, we're going to look at, you're going to be given some parallel lines, some transversals, and based off of all of these different kinds of angles, we would be able to figure out each measurement. So if I look at example 1 here, one of the more basic examples, it says angle 1 is 65. So I'm going to label this as such right here, 65. Okay. And then I want you to find the rest here. You don't necessarily need to go in particular order here, but you'll be able to figure out these angle measurements based on all the relationships. For example, angle 2. Well, I can say angle 2 is a linear pair to angle 1. Pair to angle 1. And then from what we know last chapter, a linear pair means a supplementary, so 180 minus 65 gives me 115 degrees. We can say angle 3 is vertical to angle 1. So therefore, it would be also 65. Likewise, we could have said angles 2 and 3 are a linear pair. Different reasoning, but still will reveal the same answer. We could say angle 4 is vertical to angle 2. So therefore, that has to be 115. Or we could have said 1 and 4 are linear pairs, 4 and 3 are linear pairs, but again, it would yield the same answer. Let's go down to the bottom of our figure. So we got angle 5 here. So with this one, again, you got a variety to go with it. I could say that it is corresponding to angle 1. And then from our conclusions, that would mean angle 5 is also 65. And then we could utilize the same things for the other angles here. We could say, oh, angle 6 is, let's just do something different. It's alternate interior to angle 4. So therefore, it's also 115. We could say 7 is alternate exterior to angle 1. So therefore, it's 65. We could say angle 8 is, I don't know, a linear pair to angle 7. So therefore, it's 115. These reasonings here on the right side are not the only reasons, like what we said. We could have many different reasons, but the angle measurements themselves will always be that amount here. Yeah, we will skip example 2 because it's literally the same thing as example 1 with just a different number. So let's look at example 3. So example 3 says angle 5 is 82, so I'm going to label that as such, and then to find the rest. Well, if I look here, it's, again, different ways going about getting to the same answer. If I start with the letter A, angle 1, what would you guys think? Well, maybe we don't want to start with angle 1. Maybe we don't know anything yet. But we definitely know all the angles around angle 8 here. We know 2 and 8 are linear pairs, so that means angle 2 would have to be 98 degrees. We know 5 and 8 are the same because they're vertical angles, so therefore, where is is 5. 1, 2. Oh, I labeled the wrong one. My bad. I'm sorry. Well, I mean, it still yielded the same thing here. So we still had 98 for 2. This was 82. So that means angle 8 must have been 82 degrees. And then angle 11 and angle 2 are the same, so they're both 98. So how does that help us now? Well, let's say we wanted to get angle 1 now. I wanted to say to ourselves, well, how can I get angle 1? Well, the way I would look at it is this. I'm going to use a different color here. Let's pretend we were comparing 1 and 8, or 1 and 2. Well, if we're comparing 1 and 2, that means this part on the right side doesn't exist. And then, the way I would do it, and the way I suggest this to students, is maybe turn your paper to the side here, so you look at the parallel lines going from left to right instead of up and down, and then your transversal cutting through them. Because then we would see, 1 is on the outside, 2 is between my two lines, and they're on the same side of the transversal. So that means 1 and 2 are corresponding, and therefore they are the same, so they are both 98. Which then we can use the same logic to get the left side that we did for the middle by using linear pairs and vertical angles. So if I did this here, 1 and 7, well, linear pair, so that's an 82 degrees here, which means angle 4 is 82 because it's vertical, it's 7. And then 10 and 1 are the same, so that's 98. Now if I want to get the right side here, well, it's the same logic as if I ignored this left side here, ignored that line, and I want to look at, say, angles 8 and 9. Well, 8 and 9 are corresponding, so therefore they have to be equal. So they are both 82 degrees. And then going with the same logic, we could say, angle 3 is 98, angle 6 is 82 because it's vertical, and angle 12 is also 98. Alright. Again, if you got any questions, make sure you pause the video, rewatch it, and see if you can understand it. If you feel pretty good, let's look at example 4 here. Okay. So with example 4, we've got a whole bunch of lines crossing here. But notice only these two lines right here are parallel because of how it's being marked. So therefore, the other two lines are my transversals. In this case, they gave you that, make sure I label it correctly this time, angle 12 is 121, angle 6 is 75, and now find the rest. Well, if this was me doing it here, I would probably look at all the angles around angle 12 first, because we know when it's in a drawing like that, we can utilize vertical angles and linear pairs to find the rest. So that means angle 7 must also be 121. Angle 11 must be 180 minus 121, which is going to be 59. I believe, yeah, 59. Sorry, doing that in my head here. And then that means angle 8 will also be 59. That to me is the easier one because, like I said, you got all the vertical angles and the linear pairs going for you there. So let me actually label this too. 59, 121, 59. Okay. Now, if I was probably doing this here, I also see that 1 and 6 are vertical angles. So therefore, angle 1 has to be 75. Alright, so now that we got all that, now this is where we gotta utilize some logic and combine different things we've done. Well, I can figure out what angle 4 is because 4 and 7 are what kind of angles? You'd be correct if you said that they were consecutive or same side interior angles. So therefore, angle 4 would also be 59 degrees. Likewise, you could have compared 11 and 4, said they are corresponding, so they are the same. So that would be 59. Which also means, if I look on the right side here, 6 and 14 are corresponding. So therefore 14 is also 75. And then 6 and 10 are consecutive or same side interior angles. So I'm going to do 180 minus 75, which is going to be 105. So this is 105. Which then helps us get that bottom right corner because 9 and 14 are vertical, so that's both 75. And 10 and 13 are vertical, so it's also 105. Let me just write this down, 105, 75. Okay. So now we've probably got the hardest angles to go with here, 2, 3, and 5. Actually, we can look at them with angle 3. Because angle 3 is actually what? It's vertical to angles 3 and 4. And we said 4 is already 59. So angle 3 is also 59. Now, when you get to this spot here, these are usually the last two angles that students get here. When you get to these last two steps, there's many ways to go about doing this. All depends on what logic or what things that you know. The way I look at it here, and what I'm going to show you again, there's another way, is I'm going to trace out this parallel line. Well, if I look here, this line is made out of these three angles, angles 1, 2, and 3. Well, we already know angle 1 and angle 3, so therefore to find angle 2, since it does form a straight line, I would take 180 minus 75 plus 59. So 75 and 59 is going to be 134, so 180 minus 134 gives me, I can't think here, 46. Right, yeah, 46. So that means angle 2 is 46, which then means now for angle 5, since angles 2 and 5 are vertical, is also 46 degrees. Okay. So just think of it like a puzzle. You gotta take it piece by piece here. You didn't necessarily have to go with the steps that I did here. I just found these to be the easier way to go about doing it. Okay. Let's look at these next two examples here. And again, if you feel like you want to try these out, because normally if I was in class here, I probably would have you guys try 5 and 6 and then we'll come back together. So if that's what you want to do, you can pause the video now and then watch it to see if you got it correct. So if I look at angle example 5, sorry here, it's angle 7 is 38 and angle 10 is 102. And then to find the rest. Now, the reason why they give us two angles here is because of this. Actually, let's just look at some angles first here. So again, the easiest thing to do is when I got the two lines crossing each other, the easiest thing to do is look for the angles that cross where the two lines are. So here, 5 and 7 would be the same because they're vertical, so 38. 8 and 6 will be the same, and to find them, since 8 and 7 are linear pairs, I would take 180 minus 38, which gives me 142. So both 8 and 6 are 142. And then the same thing for the top right here. Angles 10 and 12 are the same, so 12 is 102. 9 and 11 to find those, because they are the same. 9 and 10 are linear pairs, so I take 180 minus 102, which gives me 78 for both. Okay. So we figured out the corners here. And now we just need to find the rest. And once we find an angle within that one corner, we're pretty good to find all the other angles. Let's leave one here. Now the thing about this here, what makes this problem trickier, we'll say, is this. Remember with the last section, these angle pairs only exist if the angles are going along the transversals here. So these two lines right here and here are my parallel lines, which makes then these other two lines right here, because they're not marked with the arrows, those are my transversals. So what does that mean? So what that means is that even though, say for example, 4 and 8, Even though technically from last section we said angles 4 and 8 are corresponding, that's a true statement. But because those lines there are not parallel, there is no mathematical angle relationship there. So I have to go along the transversal that's not parallel with the other two lines. So that means 7 and 15 are the same angle measurements because, again, the arrows in black are my parallel lines, pink is my transversal. So I can go along the pink here. I cannot go along the black in this case here because that means it's going through the two pinks which aren't parallel. So 7 and 15 are 38. Which then makes 8 and 16 the same, so they're both 142. Which means 6 and 14 are the same. And what we're missing here, 5 and 13 are the same. So the same logic applies to this upper part here. Again, I can only go across this line right here. Going this way, I can't do because it would go along non-parallel lines. So that means 9 and 1 are both 78, along with angle 3. 4 matches up with, I think it's a 12 there. Yeah, 4 matches up with 12, so they're both 102, which means angle 2 is also 102. Right. And now, again, if you're confused, pause the video and rewatch it again. And the last example we have here is, again, with our parallel lines and our transversals. Notice again, the only lines that are parallel are the one with the arrows, and everything else is a transversal. So again, if I marked it, parallel, parallel, transversal, transversal, transversal. Alright. So I said angle 2 is 41, so I'll label that here. Angle 5 is 94. Angle 10, yes, angle 10 is 109. Alright. And then obviously find the rest. Again, the easiest things to do first, and this is my opinion, but the easiest thing to do first is to look at vertical angles and then linear pairs. And then I usually go next to corresponding angles, and then after that, it's really just any of the other angles can go in any order. So if I go in that particular order here, I unfortunately don't have any vertical angles, but I do have linear pairs. 5 and 4 are linear pairs. So that means angle 4 is 86. Well, unfortunately there's no more linear pairs per se because 10 and 9 and 8 all make up 180. So I can't just divide it by 2. There's nothing that says those two angles are congruent either. So the next thing I want to look at are corresponding angles. Well, that actually helps me because angle 10 and angle 7 are both the same. They're both corresponding, so that would be 109 also. Put that here. And then since we found angle 4 is 86, that also means that angle 1 must also be 86. Well, that actually opened up another avenue here because now that I got angle 7, well, that means angle 6 must be linear to angle 7. So it's going to be 180 minus 109, which is going to be 71. So this is going to be 71. Alright, so now we have 3, 8, and 9 left. Well, I can figure out angle 3 here because just like 2 examples ago, these 3 angles here, 1, 2, and 3, help create a line. And I know 2 out of the 3 angles. So I could take 180 minus 86 plus 41. So that's what, 127. So 180 minus 127 is going to be 53. So that means angle 3 is also 53. Alright. Now, Again, many different ways about going to do this. It just all depends on what you see. If you know for a fact, if you know what the angle measure is for a triangle, how many, what if I have three angles in a triangle, what's the degree measure when I add them all together? If you know that, then this makes the problem a whole lot easier. If you don't know that, well, you can still utilize the lesson now in order to figure it out. I'm going to tell you right now, angles in a triangle add up to 180 degrees. How does that help us? Well, look at that. We got two triangles here. We know two out of the three angles. So I could just take the two angles, add them together, and subtract it from 180. But if I want to utilize the lesson that this is, well, I would say angle 2 and angle 9 are alternate interior, so they're both 41 here. Now you might think, oh great, so that means angle 3 and angle 8 are alternate interior, so they're both 53. Not exactly here, because if I look, angle 2 is created from, let me do a different color here, this green. Angle 2 is made from this line here along with this line. So that's fine. It takes up, the parallel lines and a transversal. Because angle 2 and 9, it's still the same transversal. It's still the same. It's the other parallel lines. The other line's parallel to it. Whereas angle 3 and 8, well, angle 3 is made from this transversal, and this parallel line, and this other transversal. So the angle is created from two transversals, whereas angle 8 is created from not only two transversals, but two different transversals. Yeah, you got the one that's the same here, but then it's created from this one. So that's why 3 and 8 cannot be alternate interior. But, again, using the lesson we're doing here, I can figure out what angle 8 is because I've got three angles here that form a straight line. So I can take 180 minus 109 plus 41, add it together, which is going to be 30. Let me just make sure. Yeah, it'll be 30. Okay. So that, ladies and gentlemen, is how you figure out these different angle measurements with the different, the angle relationships. Okay. Again, if you have any questions, go back to the video, rewind the video, and look at the different examples again. In this packet too, you also have parallel lines, transversals, and algebra. This is going to be a whole lot easier than this here, but I think I gave you guys enough for one day. That will end this video here. But if you feel like doing this and you want to do the problems that are in the section, hey, go for it. No problem there. But your homework is going to be numbers 1, 2, 3, and 4. Basically, this front page here of the homework. I would like you to try these 4 problems. Okay? Again, if you have any questions, feel free to email me, or ask your classmates, or watch this video again. This is Mr. Kizik signing off.